Good morning guys, welcome to Videos Online Academy tutorial. Thanks for watching our YouTube videos online. Please, if you have not yet subscribed to this YouTube channel, please subscribe now and press the notification bell in order to see all our educative videos online. Today we are going to be considering what? Physics, and under the topic called electromotive force. Electromotive force. When we are talking about an electromotive force, what do we mean by electromotive force? Electromotive force, abbreviated as EMF, is the influence that enable current to flow from a region of lower potential to a region of higher potential. I repeat again, EMF is an influence that makes current to flow from one area of lower potential to area of what? Higher potential in a circuit. And EMF is found in every complete cells. It's found in every complete cells. What do I mean by that? Every complete cells has a source of EMF. EMF has a relationship with what? With current. The relationship between current and what? The relationship between current and EMF of a cell. EMF of a cell is given as I equal to EMF of a cell all over R plus what? External resistance plus what? Small letter R. Now, the relationship between current and EMF of a cell is what? Is given as what? I equal to EMF all over external resistance plus what? Internal resistance. While I is equal to the current measured in ampere. The what? The R is the external resistance. The external what? Resistance measured in what? Measured in ohms. Measured in ohms, the external resistor. And the R is the internal what? Resistor. That is the internal resistance of the what? The external resistance of the EMF cell. Of the EMF what? Cell or source. Now, which is also measured what? In ohms. It's also measured in ohms. Also measured in ohms. We also have what? We also have what? The E itself, which is the what? The script E is the EMF. That's the electromotive force measured in volt. The electromotive force. Motive force measured in what? Measured in volt. It means that the what? The unit, the SI unit of what? Of electromotive force is volt. Is volt. Now, another thing that we need to know that we can make what? The EMF by sort of formula by cross multiplying. We have what? EMF is equal to what? I into bracket what? R plus what? R. Now, meaning that what? The EMF is equal as what? IR plus what? I times capital letter R plus I times what? Small letter R. So we have what? We call it that IR is what? Is voltage. Recall that what? Recall that what? V is equal to what? IR. So EMF is equal to V plus what? IR. Now, as you can see, we have V here, which is the what? The potential what? The potential difference. The potential difference. Now, where V is what? Potential difference. Where V is equal to what? Potential what? Potential difference across terminals. Potential difference between what? Across terminals. What's the difference between what? The difference between EMF of a cell and potential difference PD. What's the difference between what? The EMF of a cell and what? Potential difference. Now, as I've already said, I said EMF is the influence or is the force that make what? It is what? It's the influence that make current to travel from a region of lower concentration or from a region of lower what? Potential to a region of what? Of higher potential. So it means that EMF is like a what? A driving what? It's a driving force that make what? Current to flow from a region of lower potential to a region of what? Higher potential. Why the potential difference is the what? Is the energy released or the work done when current moves from one point to another point in a circuit. Now, two different things entirely, but both are measured in volts. Both have similarity, both are measured in volts, and they are interchangeably what? Used. So try to know the difference between what? The EMF and what? And the potential difference. We have different source. So that's that about the difference. Now we're talking about different source of what? Of EMF. Different source of EMF. Talking about different source of EMF. We have the popular one is the batteries. We use batteries as well. Source of what? EMF, the generator. The generator. They have what? The source, the batteries, the generator. They have the foil cell. The foil cells. They have the solar what? The solar cells as well. So these are the sources of what? EMF in the what? In the cells. And the electrical symbol, the electrical what? Symbol for the electrical symbol for what? For EMF is given as well. The electrical symbol is represented by what? A long what? A long positive end and a short negative end. Now this EMF is EMF of a cell. Is EMF of a cell with negligible what? Resistance. Now EMF with negligible what? Internal what? Resistance. Negligible internal what? Resistance. Now as you can see here, there is no small letter R, negligible what? Internal what? Resistance. There is no small letter, there is no resistance in this EMF. So it means that this EMF has negligible internal resistance. The resistance is very, very what? Small. So that is why whenever you have what? An EMF without internal resistance, that internal resistance, small letter R, is taken to be what? Is ignored because it is very, very small. So now the EMF with internal resistance is this is the internal resistance R, and this is the what? The EMF. So this is how we represent what? This is how we represent what? An EMF with what? Internal resistance. This is internal resistance R, and this is the EMF, positive, negative. So this is EMF with what? With internal what? With what? Internal resistance. With internal resistance R. So these are the two ways to represent the EMF in a circuit of EMF cells in series and in what? And in parallel. Arrangement of EMF cells in series and parallel. Now, for the series arrangement, now when you're talking about series arrangement, for series arrangement, now when EMF is arranged in series and they are facing the same direction, when EMF cells are arranged in series and they are facing the same direction, how do we what? How do we find the combined what? The combined EMF in that what? In that circuit. For instance, if I have an internal resistance and EMF, I have another internal resistance with EMF, another internal resistance with what? EMF. Now, this is plus negative, negative plus negative. Now this is R1, this is R2 internal resistance, R2 internal resistance, R3, and this EMF 1, EMF 4, 2, EMF 3. And look at this. These are connected in series. They are connected side by side. And these EMF are facing the same what? They are facing the same direction. So in such a situation, now the effective EMF or the combined EMF, or you can call it what? The total EMF, which is what? Which I will denote by what? The total EMF source with what? T. In this arrangement, whenever they are facing the same direction and they are in series, is equal to E1 plus what? E2, EMF 1 plus EMF 2 plus EMF what? 3. So this is how you calculate the what? The combined what? EMF or the total EMF. And the combined resistance The total resistance will be given as what? R1 plus R2 plus what? R3. So for series arrangement in same what? Same direction. In same direction, into bracket what? Same polarity. Please note that. Same direction, same what? Or same polar what? Polarity. So whenever they have same direction and same polarity in series arrangement, you add it up, you add everything up. So now, but in different what? Direction now, when you have different direction, different what? Different direction, or opposite direction, or reverse direction, whichever you can call it, different opposite or what? Or reverse what? Direction. When you have reverse what? Polarity. So different what? Direction. When EMF of a cell which are in series are arranged in what? In opposite direction or different direction, what do we have? What will be our total what? EMF. So for instance, now if I have so if I have something like this, and the EMF here is, and the EMF here is, the EMF here is E1, the EMF here is E2. Now my total combined resistance will be what? E2 minus what? E1. You find the difference. The what? The total resistance will be the difference between the EMF. It can be E2 minus what? E1. So that's how you find what? The total what? The total what? The total EMF of that cell. But the resistance also you what? You add up the resistance together. You don't need to separate, you add up the resistance together. The total resistance here will be RT equal to what? R1 plus what? R2. So while the EMF, you subtract the EMF from what? From each other. So that's that about what? That's about series arrangement. Now the parallel arrangement of EMF cell, the parallel arrangement of EMF cells in what? In the circuit. Now, when you have what? The parallel arrangement of an EMF in circuit, for example, now if you have something like this, so in parallel like this, now when you have a circuit in whereby the what? The EMF is what? The EMF is arranged in what? In parallel. So how do you calculate the effective what? EMF? How do you get the what? The effective what? EMF. So to get the effective EMF, the total EMF or effective EMF, the total EMF or the effective EMF are equal to one another. The total or effective EMF will be what? Equal to E1, EMF 1, EMF what 2, and EMF what 3. That is, the EMF is the same in what? In parallel what arrangement? In parallel arrangement we have equal what? Equal EMF throughout. That is, the total EMF is equivalent to individual what? EMF in what? In parallel what? Arrangement. While the resistance R1, internal resistance R1, R2, R what? 3 is calculated now. The total internal resistance is obtained by finding the what? The reciprocal of individual, by adding up the reciprocal of individual resistance, by adding up the reciprocal of individual resistance. That is 1 over R1 plus 1 over R2 plus 1 over R3. So this is how you calculate the internal resistance for the what? For the parallel what? Arrangement of what? Of EMF. of EMF and internal what? Resistance. You can see for parallel arrangement, the what? The EMF, the total EMF is equivalent to individual what? EMF, which is total EMF is equal to R, EMF 1 equal to EMF 2 equal to EMF 3. While the internal resistance here, the sum of internal resistance here, total internal resistance is the reciprocal of individual, sum of the reciprocal of individual internal resistance. So that's that about the arrangement of EMF in parallel and in series. Now let's go into the what? Into the questions we have before us and solve it using this what? These rules of what? Of arrangement. So now, the question number 1 says, when two cells of negligible internal what? Resistance, two cells of negligible internal resistance, an equal EMF denotes a what? A EMF 1 and EMF what? 2 are connected in parallel. The combined EMF E is given as, now note something, two cells of negligible internal resistance and equal EMF denotes E1 and E2 are connected in parallel. Now, the EMF is connected in parallel, which is what? EMF 1 and EMF what? 2 are connected in parallel, and they have negligible what? Internal what? Resistance. That is the what? The internal resistance is very, very small, that it is ignored. So this is what? This is the sketch. Let me just say, assuming we have a circuit like this, and the EMF is connected in what? In parallel. It's just a sketch plus, and this EMF 1, EMF 2. Now, let's say what? The combined EMF E is given by what? Dash. Now, whenever an EMF is connected in parallel, whenever they are connected in parallel to one another, so the total or combined internal what? The total or combined what? EMF is given as what? E subscript T equal to what? EMF 1 equal to EMF what? 2. So this is the final answer. That is, the EMF, the total EMF is equal to individual EMF connected in what? In parallel. So ET is equal to E1 minus equal to E2. So that's the final answer. So what does this one? This one, which option is correct here? Option C. Option C. The answer is option C. So let's go to number 2 question. That one is a straightforward question, so I don't need to waste much of my time on it. So number 2 question. Given that this is the diagram now, this is a diagram of arrangement of the what? Of cells. 6 identical cells, each of EMF 2 volts, are connected as shown above. 6 identical cells, each of EMF 2 volts, are connected as shown above. The effective EMF of the cell is dash. The effective EMF of the cell is what? Now we have to calculate the effective EMF of the what? Of the cells. And we are told that each EMF is 2 volts. Now let's draw out the thing here out here. We have EMF. Now, don't forget that we are told that this EMF is 2 what? 2 volts. You have plus, negative, negative, plus, plus, negative, plus, negative, plus, negative, plus, negative. So these two, they are 2 volts each. 2 volts, 2 volts, 2 volts, and 2 volts. Now, if there are 2 volts, 1, 2, 3, 4, 5, 6. Now, the combined EMF of the cell is what? The combined EMF of the cell is what? Now, let's look at this. together. Let's look at this together. Now, you can see here, this set of EMF here is connected in series. This is EMF 1, EMF 2, EMF 3, EMF 4, EMF 3, you have EMF 3 here, EMF 4, and EMF 4. Sorry, EMF 4, EMF 5, and what? 6. And these EMF are connected in series together. These EMF are connected in series together. And that says you calculate the what? The E total. Now, for example, now look at this. These are connected in series to one another, but they are oppositely, they are facing each other. They are opposite to each other. The direction is different. This one is facing this. So it means that this EMF now minus this EMF 2. So it becomes, this one becomes 0. This one is 0 here. There's nothing here. 2 minus 2. This one is equal to 0. The EMF here is what? 0 for here, because they are facing each other. They are in opposite direction. This one also, EMF 3 is what? Minus what? EMF 4, which is 2 minus 2. We still have 0. But when you get to this what? EMF what? 5 and EMF what? 6. They are facing what? The same what? Direction. And because they are facing the same direction, it will be addition. So it will be what? EMF 5 plus EMF what? 6, which is 2 plus 2, which is equal to what? 4 volts. So now add everything together now. We now have what? The total EMF of the cell. We now have what? 0 plus 4 volts. We have what? The answer here is 4 volts. The total EMF of the cell here is 4 volts. Is there answer there? Yes, answer is there. We have 4 volts. So that's that about what? About that. Now, the next one is 3 similar cells of an EMF. 3 similar cells of an EMF 2 volts. And internal resistance 2 ohms are connected in parallel. The total EMF and the total internal resistance respectively. Now, 3 similar cells of EMF volts 2 volts and internal resistance 2 ohm are connected in parallel. Now, 3 similar cells, the same cells, are connected in what? In parallel. Now, if I have an internal resistance and a cell in parallel, connected in parallel to each other. So we have what? We have another internal resistance here with an EMF connected in parallel. And lastly, it is 3 similar what? Cells connected in what? In parallel. So we have something like this. So the internal resistance of what? The EMF is 2 volts. The EMF is 2 volts, 2 volts, 2 volts. And the internal resistance is 2 ohms, 2 ohms, 2 ohms. Now, the question says, calculate the total EMF. That is, you calculate the total EMF. And then the total internal what? And the total internal resistance. Now, how do you go about this? You have the parallel, the EMF is arranged in parallel. So, and in a parallel arrangement of what? Of EMF, in parallel arrangement of EMF, we said that the E total, that is, the total EMF will be equal to EMF 1 equal to EMF 2 equal to EMF 3, which is equal to 2 volts. So the total internal resistance here, the total EMF here is what? 2 volts rather. So it is what? 2 volts. Well, now let's check the internal resistance. The internal resistance arranged in parallel is obtained. Total internal resistance arranged in parallel is obtained by saying the reciprocal of the total internal resistance equal to the sum of the reciprocal of individual what? Internal resistance. So plus what? 1 over R1 plus 1 over R2 plus 1 over R3. So now what is R? 1 over RT is equal to 1 over 2 plus 1 over 2 plus 1 over what? 2. So command now we have what? 1 over RT equal to 1 plus 1 plus 1. We have 3 all over 2. We cross multiply. So we have what? 3R subscript T is equal to what? 2. Now divide both sides by 3. We have 3 here, cancel 3. So we have the total internal resistance will be 2 divided by 3, which is equal to 0.66. Now, approximately 0.66 ohm, approximately 0.7 ohms. Approximately 0.7 ohms. So 0.666, approximately 0.7 ohms. So the total internal what? Resistance is 0.7, and the total EMF is what? 2 volts. So we have the answer is 2 volts, comma what? 0.7 volts. Ohm. 2 volts, comma 0.7 volts. So the option is option B. Option B. Option B. Now that's that about that. Now let's a cell of EMF 12 volts and internal resistance 4 ohms is connected to an external resistance of resistor of resistance 2 ohm. Find the current. Now the question is, a cell has EMF of what? EMF of 12 volts and internal resistance of 4 ohm. R equals to what? 4 ohm. It's connected to an external what? Resistance of 2 ohm. External resistance of 2 ohm. Please note that. Calculate the current I. You have to calculate the current I. This is question number 4. So here the cell contains EMF of 12 volts, internal resistance of 4 ohms, external resistance of 2 ohms, and we have to calculate the current. So the current is just the EMF all over R plus the EMF is equal to I equal to EMF all over R plus what? So the current is given as I equal to what? EMF all over what? External resistance plus what? Internal what? Resistance. We have the current I is given as what? External resistance over so to obtain what? The current I of the what? Of the circuit. The current I of the circuit is given as I equal to what? EMF E all over what? All over R, the external resistor, plus the what? The internal resistor, small letter R. So how do you now furthermore now is that I will now be equal to what's your EMF? EMF is 12 all over, what's your capital letter R? Capital letter R is 2, while your internal resistance is what? 4. So when you add it together, I is equal to 12 all over what? 6, which is equal to 12 over 6 is equal to what? 2 ampere. So the answer is 2 ampere. What is the option? Option B. Option B. That's how you calculate it. I is equal to EMF all over R plus what? Which is the external resistance plus the internal what? Resistance letter R. Now, number 5 question. Number 5 questions. So that in the diagram given, what's the diagram given? The diagram is like this. So you have an external resistor of 7 ohms. We have EMF P and we have EMF what? Q. EMF P has what? 1.5 volts and EMF what? Q has 2.0 volts. Now this one has internal resistance. That is internal resistance RQ equal to what? 1.0. But we don't know the internal resistance of RP is not what? It's not given. In the diagram now, given circuit, this set P has an EMF 1.5 volts and an unknown internal resistance R, while the cell Q has EMF 2.0 volts and internal resistance of 1.0 ohms. If the answer is what? Now the current that flows through the circuit is what? The current that flow through circuit is what? 50 millimeter ampere. Now when you have 50 millimeter ampere, it means 50 times 10 raised to the power minus 3, because millimeter is what? It's 10 raised to the power minus 3 ampere. So it means that 50 over 1000, and you do it or you press your calculator. So we have 1, 2. So this one is what? 0.05 ampere. So your current flow, the current flowing through what? The circuit is what? 0.05 ampere. Now, then find R. We have to find this R here. So I term it RP. So as for proper what? Indication. So we calculate what? The internal resistance R of what? Of the P. Of the P. Now, you know that what? Look at this. The EMF in this circuit now. Look at this. This EMF here, Q here is in opposition with what? EMF P. So the total EMF here will be what? The total EMF here will be EMF Q minus EMF what? P, which is 2.0 volt minus 1.5 volt. So which is equal to 0.5 volt, because 2 to give you 0.5 volts. So if this is 0.5 volts, now what about the resistance here? The internal resistance, the total internal resistance will be given as what? Rp plus 1.0. So the RT here, the total internal resistance will be given as what? The internal resistance of what? Of cell P plus the internal resistance of what? Of cell Q. The internal resistance of cell Q is what? 1.0. So it means that 1.0, so that's Rp plus 1. So now remember that I itself is given as EMF all over R plus external resistance plus what? Internal what? Resistance. External resistance plus what? Internal resistance. Now, substituting this parameter now, what do we have now? Now this one will be what? This one will be what? Total EMF. This one will be total EMF. This one will be what? Total internal what? Resistance. Total EMF, total internal resistance. Now let's substitute now. The total internal resistance is Rp plus 1.0, and the total EMF is 0.5, and the current given here is 0.05 ampere. So we have what? 0.5 equals, what's your EMF here? Sorry, yes, 0.0 what? The current here is 0.05 equals what? The EMF given here is what? 0.5 all over what? Now, your external resistance is 7 plus, then the total internal resistance is what? Rp plus 1. Rp plus 1. So, if you cross multiply now, what do you have? 0.05 in bracket 7 plus Rp plus 1 equal to 0.5. So when you multiply it through now, this one will be 0.05 times this will be 0.35. Okay, let's first add this one together first. 0.05 into bracket. 7 plus 1 is 8 point Rp equals 0.5. So when you multiply this one, 0.05 times 8 will give what? 0.40. 0.40 plus Rp equals to 0.05 times is 0.40 plus 0.05 times Rp, 0.05 Rp equals to 0.5. So when you take down to the other side, this one is 0.05 Rp equal to 0.5 minus 0.40. So we have 0.05 Rp equal to 0.1. So we have to multiply by 0.005, 0.005. What do we have here? So cancelled out. This one is equal to what? When you press your calculator, let me just use manually now, we have what? We have 1/10 multiplied by 100 all over what? 5. So once you have cancelled out here, we have the answer here will be 2 ohms. The RP here will be 2 ohms. We have 2 ohms here. So the answer here is what? 2 ohms. We have 2 ohms here. 2 ohms, 2 ohms. So the RP here is what? The RP here is 2 ohms. The RP here is 2 ohms. The RP here is 2 ohms. So if this RP is 2 ohms, what is the total internal resistance? Just go back and substitute. Go back and substitute. Now the RP is what? Is 2 ohms now. So the total internal resistance now will have what? R is equal to what? RP is 2 ohms plus 1. So we have 3 what? Ohms. So that's total internal resistance R. So this answer here is what? 3 watts. 3. A cell of EMF 1.5 volt is connected in series with 1.0 ohm resistor and a current of 0.3 ampere flow through a resistor. Find the internal resistance of the cell. Now we are asked that we are told that number 6 here. We are told that the EMF of the cell is what? The EMF of the cell is 1.5 volts. Connected in series with what? The external resistance of what? 1.0 ohms. And the current flowing through the resistor is what? I. The current flowing through the resistor I is equal to what? 0.3. Calculate the internal resistance. So what is the internal resistance that you are going to calculate now? The internal resistance now here is the internal resistance. How do you calculate the internal resistance? Recall that I is equal to EMF all over R plus internal resistance. External resistance plus internal resistance. So we have what? What is your I? 0.3 is equal to what? Your EMF is 1.5 all over. What is your external resistance? 1.0 plus your internal resistance. That's what we are looking for. R. So you must multiply. So 0.3 into bracket 1.0 plus R equal to 1.5. So this one is what? 0.3 plus 0.3 R equals 1.5. So 0.3 R equals 1.5 minus what? Minus, check this one to the other side. Minus 1.3, 0.3 R equals what? 1.2. R is equal to 4 ohms. So we have come to the end of today's class. Please, if you have not yet subscribed, please subscribe to this YouTube channel and let us know how this video has helped you.